So the first thing I want to do is I want to go over how to read this chart. So I sent it to you, but it didn't really talk about how to look at it. You notice all the arrows either go down or they go to the right. So you read it from left to right. So the problem that you've asked me to work is beginning with grams. So you're over here on the left-hand side, and you want to go 2 grams on the right-hand side. So it means I have to go from grams to moles, and in order to do that, I have to use this conversion, the 1 mole over a molecular weight. And then I'm going to have to go from moles to moles. So I'm going to put the moles that I want on top, divided by the moles from the given. So that's whatever I started with. And then I need to go from the moles I've got here to grams. And this time you notice that the conversion's upside down. I'm going to have to find the molecular weight of whatever moles these are. And then that will ultimately give me grams. So we're using this top half up here for the problem that I'm just about to work. So here's the question part. You have the background of what ammonium phosphate is, the formula, and how we make it for fertilizers. So the actual question is, what mass of ammonia is consumed by the reaction of 6.4 grams of phosphoric acid? So your first step that you always want to do is you need to write the balanced equation. So I know that it says I'm going to make the ammonium phosphate. So I need to do the phosphoric acid. So I've got H3PO4 plus the ammonia, which is NH3. And that's going to yield the NH4. They were so nice to already give you the formula. And then I've got PO4. So now I've got that balanced with my elements. So what I need to do is I need to know that's balanced from charge. So am I balanced on the left-hand side of the arrow with the right-hand side of the arrow? Well, let's check that. I've got 3 hydrogens here and 3 here. So let's do hydrogen last. I've got 1 PO4 on the left, and I've got 1 PO4 on the right. So I'm done with that. Now I've got 1 nitrogen here, but now I've got N, but there's 3 of them, so I've got 3 nitrogens on the right. So I'm going to put a 3 out in front here. So now let's go back and do our hydrogens. I've got 3 first right here, and then I've got 3 times 3 is 9. So 9 plus 3 is 12. And then over here I've got 4 times 3, which is 12. So now it's balanced. So if it's not balanced, you can't get the right answer. And a lot of times that's what happens is you forget to balance it. So now once I've got it balanced, I want to label what I know. Well, the only thing it gave me was this 6.4 grams. You notice it says it's of the phosphoric acid, so I'm going to put it right here, 6.4 grams. And it says I need to know what mass of ammonia. So that's this thing right next to it. So I'm looking for that in grams. So you notice I showed you the top of that chart. So I'm starting right here. And now I need to go down to moles. So when in doubt, you always convert to moles first. So I'm going to convert my grams of phosphoric acid. So I've got 6.4 grams of phosphoric acid. Oh, the internet's going to be all weird. And now I need to convert that into moles. So in 1 mole of phosphoric acid, how much does that weigh? So that's where I'm going to go to the periodic table, and I'm going to look all that up. So I'm going to take 3 times 1.01 plus 30.97 plus 4 times 16. And when I did that, I got 98. And that's grams of H3PO4. Now, what I would do right here, just kind of as to make me feel happy, is I notice that these grams and these grams look the same. So those cancel. And in doing that, now I have moles of H3PO4. And if I go back to the chart, I'm right here at moles. So now I need to do a mole-to-mole ratio. So when I do that, I want to get rid of these moles. So I'm going to put that on the bottom. Now, how many moles do I have? Well, I need to look at the balanced equation. The coefficient when it's not written is always 1. So I'm going to have 1 mole of H3PO4. The beautiful thing it's doing. And now I need to go to the NH3, right? Because that's the grams that I'm looking for. And the coefficient in front of that is a 3. So I'm going to have 3 moles of the NH3. And again, I want to look and see if any of my units cancel. And I notice that this is moles of H3PO4, and so is this. So right now I'm sitting at just moles of NH3. If we go back to the moles chart, now we're right here. And I need to go from moles to grams. So my last step here is I need to go from moles to grams. So I need to get rid of moles, so it has to go on the bottom. So I have 1 mole of NH3. And now how much does that weigh? Well, I go on the periodic table and I take 14.01 plus 3 times 1.01, and I get 17.04 grams of NH3. Again, I want to make sure that everything cancels. I notice I've got moles here and moles here. So now I'm left with these grams, and that's what I want, right? Because originally I said I needed grams, so I'm good in that part. So now I'm going to multiply 6.4 times 3, that's a funky 3, times 17.04, and then I'm going to divide that whole thing by 98. Oh, you gotta love the internet. 98. So when I do that on my calculator, I got it's like 3.3389, and then a whole bunch of other numbers. But I need to have significant figures. So I go back to the original up here, and it says 6.4. So there's only 2. So I come to the second one, I go to the right one. It's less than 5, so my answer should be 3.3 grams of N, well, that doesn't even look like an N, of NH3. So hopefully this has helped you walk through that process, and then looking at this in addition to the chart itself to read across the top. If you still have questions, make sure you let me know, because I want to make sure you understand exactly how to do it, and if that wasn't clear, make sure you text me back and let me know.